Hello,
Hello,
hi
hi.
everybody. I'm Thiago Almeida. I'm a PM on the Azure Functions team, and I'm joined today by Paul Yuknewicz. Paul, do you want to introduce yourself?
Hey everybody, I'm Paul, and I work with the Functions team. I'm kind of the lead for the team. I also have spent a lot of time on frameworks and open source and tooling and other things too.
Cool. Yeah, so this is the June edition of the Azure Functions Community call, and we're here to tell you all about the news from last month when we had the Microsoft Build conference, and we had quite a lot of announcements that came out. It's probably one of the biggest list of announcements that the Functions team has released recently. So we wanted to talk you through in case you missed out on the news, and also go deeper into both flash consumption and OpenAI, do a couple of demos on those areas as well. So without further ado, we'll kick off. Paul, do you want to take this one?
Sure. I guess we should see how many announcements per second I can do. All right. So a number of things went GA, and then we have some new things for you to try in preview. So one thing we're really excited about, so Azure Functions, the programming model, you've probably seen that it's been able to work on Azure Container Apps. So you can use like the full Container Apps environment, the Container Apps networking, all the mechanisms around it in Container Apps with the Azure Functions programming model by deploying a function into a Container Apps environment. So that has finally gone GA. We're excited about that. We're excited.
And we had Ramya join us a couple of months back that cover it in a deeper detail as well. So if you're interested in that one, check it out.
Go back. Another one that's near and dear to me. So I'm one of the contributors for Dapper, which is a open source for building distributed apps. And now we have a supported GA extension for Dapper that runs with functions. So you can use all the APIs or virtually all the APIs from Dapper, and you can use them in the programming model of functions. So they effectively look like triggers and bindings for Dapper. So it lets you kind of interop between the two universes. And one, I like to use the Dapper extension together with functions on Container Apps, because that is an easy way to get service discovery between the multiple functions and the microservices that you might have in an environment. Another cool one, people have been asking for HTTP streaming for a long time, which helps with performance and helps with a number of scenarios where a stream is the kind of object you want to work with. So now that's GA in Node.js and JavaScript functions. Another cool one, also asked for performance and for scale reasons, we can now use the blob trigger with event grid. So you could use event grid to be the trigger source for your blobs. And we now have templates and VS Code integration to make it easy to build one of these things. And Thiago, I think you had some stories about this. Where are some cases where this might help?
Yeah, I will do a demo a little later as well of this functionality. But usually when we have customers that want to upload a considerable amount of blobs or have websites that people can upload blobs through the website, or trading partners that are sending blobs into your own blob storage account, and they want to process those as fast as possible. And with the event grid based blob trigger, because the event grid will notify the function app that there's new blobs in there, it will be a lot more responsive to be able to trigger your function and go through those blobs as fast as possible. And that's one of the reasons why for flex consumption, this is the method that we support for blob triggers, so that it combines the speed of scale of flex consumption and the fast notifications that Event Grid provides for the new blobs uploaded.
And I was checking it to Event Grid, and I saw that they have a new mechanism for kind of pull and push based, which would help you deal with the back pressure. Is that something that in the future maybe we'd be able to take advantage of?
Yes, absolutely. We're working with the team, the SDK team for Event Grid, to bring that pull based execution for Azure Functions as well. Overall, not just for blob, but for overall purposes, which will be very helpful, especially to enable VNet pulling, for example. If we need to get a function behind a VNet that needs to pull from event grid, then that will make it possible.
And that, as far as if you're doing, let's say, pub sub, now both sides of the wire have a little bit of control about around the messages. Like you can fire hose and push a bunch of messages or events, but then the function could actually decide when it's ready to pull also, right?
Right, exactly. Yeah. So there's no concerns about the downstream components being too throttled, because the function could slow down and pull from event grid slower.
Yeah,
when we bring that in.
Seen that request for a long time, so that's really cool. All right, so those are the GA announcements. Now going into the preview, Flex, which we have talked a lot about, and now we'll talk some more about, because you can never get too much. Flex consumption, our really like new and improved ideal way to do consumption, is in full preview, so everyone can go use it right away, like right through the Azure portal or the tools or through ARM and Bicep, all the different ways. So that's really cool, and I won't say anymore. I'm sure Thiago will show it. We also have triggers and bindings for OpenAI, and that's an exciting one. Hopefully we have time today to give you a sneak peek, and you might have seen it also, but whether you're doing the RAG scenario, which is like chatting with your own data, a stateful chat, or even if you want to add functionality with functions and add function calling, we have a skill assistant trigger that can help with that. So if you go get this extension in preview, it's really easy, just several lines of code to work with OpenAI and do the real scenarios, even with private data. So another one, I think we're going to show this, but a lot of times you get more confident by testing your app under load. So there's a Azure load test integration. And I think the UI even says it's better together, which is a little cheeky. Maybe we let our internal idea show through in the UI, but that's where you're going to find it. Also, we have this thing called SDK type bindings. Have we talked about this on the stream yet, Thiago?
We did in the past when Matthew talked about the .NET versions of the .NET isolated, but not for the other languages.
Right. So, so thinking about isolated functions, or basically the out of process functions, when we introduced that, we had some struggles because not all of the type system worked the same way in isolated as it did in proc. So some things I'm thinking about there would be like file streams, or working with the actual blob clients and objects. Those just didn't exist. So we're excited because we've added previews now where these SDK types can actually be used right in the trigger and binding signature. Basically, you can return a warm object with something like the blob service client, or with an actual stream, and the whole runtime mechanism understands it. So that's really powerful. That's available now in Python. And also the HTTP streams are available in Python. So just like the isolated model is getting much, much, much richer, and kind of on full parity with improc. And I think if you asked us, like the time to be using the isolated model is definitely now, because that's really where we're headed in the future.
Cool, thank you, Paul. And you can see we have a link at the bottom there, aka.ms/Azure Functions News. That's currently pointing to the blog post that we released at Build that has a link and more information about each one of these announcements. So yeah, check it out if you're interested in any of these in more detail. That blog will have the right connections for you. And with that, I'm gonna go a little bit deeper into Flex consumption and cover some of the scaling concepts that we've introduced to Flex consumption. We went public preview at Build last month on May 21st. And one of the concepts to keep in mind for Flex consumption is that apps don't really share a plan. Each Flex consumption app is its own app and plan. And you choose a memory instance size for each app. And that should be, according to your workload. More memory or a larger instance size can handle heavier executions or have more concurrency depending on your workload. But the CPU and memory will increase and decrease accordingly depending on the size. As you can see now, during public preview, we started with the 2 gigs and 4 gig instance sizes. We are working on bringing the 512 instance size as well. And more as the service progresses, we will look at introducing even more sizes as well, options for you. The default at the moment is the 2 gig instance size because we see that covers most of the customer scenarios. So it should be okay to start your first flex consumption app using the default there. And that instance size goes together with a thing that we call per instance concurrency. And that we mean the number of parallel requests that are handled per each instance of that instance size that you chose before. And while you can control the concurrency for both HTTP and non-HTTP flex consumption apps, we do provide some defaults that work for most cases. So for example, for Python, given it doesn't handle concurrent executions as well as the other languages, the default is 1. But for other languages, for the 2 gig instance size, for example, the default for HTTP is 16. And then each trigger type has its own defaults that are defined mostly by the SDKs of those sources as well. And then finally, the scaling is driven by concurrency. So if you get 10 HTTP requests coming in with a concurrency of 1, the platform will scale the Flex Consumption app up to 10, and each of those instances will be given one request, one HTTP request to handle. And of course, those instances will then be reused. So you might end up with less instances than the actual influx of HTTP requests, because some of those instances are being reused because they've finished processing already. And of course, if the concurrency is increased to 2, then the same 10 HTTP requests will give 2 executions per instance, and the app will be scaled to 5, which is pretty cool. So one thing I wanted to show here is we have a demo, and that demo basically has a function app, a flex consumption app here, and an event hub that is behind a VNet. And what I wanted to show you is one of the things that Paul called out before, called the load testing integration. So there's 2 features here. One is the load testing integration, and this will be available for you right now for any function app that you have. And then we also have a performance optimizer one that allows you to run multiple configurations of concurrency and instance size for your app. So it basically runs a load test, changes your app to the new concurrency and instance size, runs another load test, and so on. And then at the end, it shows a comparison of the results. Before load testing here, you would, if you don't have an Azure load testing instance, it'll ask you to create one, and then you can just create a test. So the only thing to keep in mind for this is that it's all HTTP based requests. So let's add a couple of requests here. The process customer feedback is the function that I want to test. I have a couple of simple customer feedback here. So I'll create a couple of requests, one for Alice, add that one, then I'll add another one just in case, from Bob Jones to that same HTTP function. So Azure load testing is checking out my function, finding out the ones that are HTTP triggered, and then they show it here for me to be able to add the requests, right? Next, you just configure pretty much like you would configure your normal Azure load test. So I'll say concurrent users per engine 150, 5 engines here. That's around, let me see, I'll probably do 200. So that's around 1,000 virtual users that this will give me, run as many requests as it can for 3 minutes for those 2 request types that I set up. And then it'll show me the results later. So I'll kick this off right now, and we can come back to this after it's kicked off. Just one thing I wanted to show is that I have app insights here for attached to that function app. And if I go to live metrics, the app is scaled to 1 or 0. It's scaled to 1 because I browsed to the function app before, but it is not processing any requests at the moment. So I'll come back to that. Cool. To talk a little bit more about the impact of concurrency, we have a very well-written blog post by me and Paul Badum from the team. But you can check it out
Shameless.
here on aka.ms/flexconsumption/http scale blog. And one of the tests we've done is for this exact symbol that I'm showcasing here in the demo, we compared load test runs with the same memory size of 2 gigs in different concurrencies, 16, 8, and 4. And you can see here that the concurrency of 4 was able to handle 32.98 thousand requests per second. And that's because the concurrency is smaller and it's scaled out to, say, 250 instances of that app. And each instance was able to then process more requests as well, because it was handling, four requests and then processing the next one. And that's how this higher throughput was achieved. And you could notice that the 8 one was kind of in between the two, and the 16 was lower, but it's not half of what was there before. So that's why it's important to run load tests to see if for your application, say if 19,000 requests per second was already good, then the 8 concurrency would be the best one to choose for your application, because it would be able to handle what you want, but the final cost of it per million requests would be smaller than the 4 concurrency. So we go much deeper into it in the blog post. Please check it out if you want to learn more about this. But this is if you need to really fine-tune things. You can just leave it with the defaults and see how your application handles. But if you want to fine-tune things or check out the difference in costing between concurrencies, then I'd recommend running some tests like this. And then the last thing that I wanted to call out as far as the features of flex consumption is it has networking support, just like you expect from other services, and the premium and app service plans options for Azure Functions as well. So inbound and outbound networking support for flex consumption. But one key thing that is interesting for flex consumption is the flex apps can share the same subnet, and each flex consumption app will take at most 40 IP addresses, even if it's scaled out to 1,000. So if your app doesn't scale a lot, you could even do with less than 40 IP addresses per app, but this is the most that it would ever take, even when scaled out, which is pretty great. So your subnets can be pretty small for flex consumption, and it'll still be able to scale to the highest value that it can scale to. And the final note is the resource provider, Microsoft.app, is required for flex consumption to work with VNet integration. It's just a note that we have here, and it's in the documentation as well. Okay, so that demo that I just showed you, it is this application here. It's in the samples and a .NET application. It takes in an HTTP request. That's the process customer feedback that we looked at before on the portal there as well when we were doing the Azure load testing integration. At the moment, it's just reading the body of the request and then sending it out to event hubs and a response to the HTTP request with a status of OK. So this is where it sends to event hubs. But that event hubs is behind a VNet, and the app is VNet integrated into that same VNet. So here, back on the app insights, we see that load testing, kicked off the load, and it's handling about 5,000 to 6,000 requests per second, with 38 instances handling that load, which is pretty nice. So it basically scaled up to a point where the concurrency setting was for the app, and then started handling all of those. And we can see here that load testing just finished sending requests, and now the app is not handling any more requests. You can see here it sent about 1,000 requests, and once it's done, it'll give us the P99 or P90 results of the latency for each request as well, which is a good thing to keep in mind. And the final thing I wanted to show for this demo is instance count. So there's a few queries that you can write to, or different ways that you can write a query to show how that instance was scaled. Maybe I can make this a little smaller. You can see here the app was scaled to 0, or at least as far as you as a customer should be concerned, the app was not processing any requests, so you're not paying for anything. But then once load test started sending requests, the apps quickly scaled to match the load that was coming from load testing, up to around 38 instances here. And then once the load was done, it came back down to 0, to no instances processing. Just one thing, when you're running these types of queries for HTTP, I recommend the requests table. For the other ones, I would recommend the traces table. So that's the first demo that I wanted to show. That just showcases the HTTP throughput scaling based on the concurrency settings and how it handles sending all those events into network secured event hubs. Any notes here for this demo, Paul, that you'd like to call out?
No, I think you hit it really well. Yeah, you went to the concurrency, which was really cool. Using together with load tests, you can right size. We should do a talk at some point too to talk about how we do the pooling and some of the cool things under the hood here.
Sounds good.
Not enough time today.
Yeah. Another demo that I wanted to show, this one is the event grid based blob trigger that we have now support for in VS Code. We started adding more tooling support for it so that it's easier for you to both test it locally and then run it in production. And this demo is one scenario that I've seen a lot of customers go through. Is basically files get uploaded to a blob container and then they need to be processed. So in this case, it's a Node.js app that we upload, or customers upload PDF files into a container. That node function gets triggered from those blobs and processes them into text using a node module that processes PDFs into text. So let's have a look at what that looks like in Visual Studio. All right, so this is the function itself. It's a node function, and it triggers from a unprocessed PDF folder and any file called .pdf. You see that the source type here is event grid, which is very important. And then once it gets hold of the contents of the blob, it is using the PDF.js legacy build to transform those pages of the PDF into text. And then finally, the return of it is this blob output that is saving those files to another container called process text in a text format. So let me have a look here. Just want to make sure I have Azure Write running for both blob and queues. And I can start debugging this function locally. Okay, it's kicking off. And then locally here, you'll see I pre-created 2 containers. One is process text and one is unprocessed PDF. I can upload a new file to the unprocessed PDF here. Let me see, employee handbook, for example. And it's there. I'll copy the URL to that unprocessed PDF employee handbook here. I just need the name. And now that we have local storage with the 2 containers that my function app expects, and I have the function in debug mode, I can execute that function right here, execute function now, and pass in that blob. And it'll execute the function, process that PDF, And then if I go into the storage again and have a look in the process text container, I can refresh this, and there's the employee handbook file with the actual text from the PDF. So end-to-end local testing. And then I've deployed this function app to Azure before. So let's have a look at what that looks like. Here we go. We have this other resource group, blob east US. My function is there, and that's the storage account it's using. And if I go into the function app here, just to have a look, we'll see under properties that it is that node 20 function app that we have deployed. And back on my storage account, I have the process text and unprocessed, processed PDF, processed text and unprocessed PDF, which are both empty at the moment, as you can see here. So I'll upload some files, probably those same files that I had there in the folder. And as those are being uploaded, we can switch over to process text, and we can see that the files are there and processed into text already. So normally with the typical blob trigger, you could have a polling mechanism. There was a polling mechanism behind the scenes that could mean it would take quite a few seconds to even minutes to pick up on those files. But with the event grid based one, it straight away executes the function, tells it that there's blobs there, and then it processes the files. Cool.
Processed files are a lot better than processed food, I think.
Absolutely.
Okay.
So those are the two demos for flex consumption I wanted to show today. We've done the previous demo before, but I wanted to give a refresher, and now this event grid one. And all those flex consumption demos are in this GitHub repo that you can check out. It has Azure developer CLI support, so you can just do AZD app from the folders, get these end-to-end deployed and running. And there are some best practices built into these samples. For example, the communication between function apps and storage is all using managed identity, user-assigned managed identity, which or system-assigned, one of the two, depending on the demo. So you can also check it out for those reasons if you need to see some of the security best practices as well for functions. Cool. And now I'll pass it on to you, Paul, if you want to do a demo of this one.
Let's do it. I know I always like to keep you wondering if I'm going to do a demo or not today.
All right, go for it.
Let's do it. Okay, so a little bit of an intro. Here's the, actually, can we show that slide? That was actually useful. Thank you, sir. All right, so here's a real use case where we're going to do some data ingestion. And so, if one of Functions' superpowers is ingesting data of all kinds. In this case, we're going to ingest files, which might be a common way that we want to data ingest to do RAG, or retrieval augmented generation, over a search. So in this picture, what we're seeing is, the functions kind of receive the data, and then we're going to do some embeddings. So we're going to extract those documents into chunks, and we're going to convert them into vector embeddings. And vector embeddings is basically the format that a vector similarity search and AI will want to use. And then we can basically, once we have things in a vector database, we can do some prompts over it with a semantic search. So that's effectively what we're showing here. So we're going to do an upload on the left, and then we're going to move to chatting our data on the right. And because we're using this RAG style, the nice thing is the data that you're sending isn't like going to the internet into the public chat GPT. It's actually going to your own vector database. And the chat models are privately working only with your own data. So like really none of that data leaves your subscription and goes to the world. So this is the way that we do enterprise scenarios, more confidential scenarios, because we're going to make sure that the data is secure and never leaves and goes to the internet. Okay, so let's, I think I will switch to my shared screen. Oh, look at that crazy picture. Sorry about that. All right, so let's start with VS Code. Um, make that bigger. Does that look good, Thiago? You can see the screen, basically.
I might need to zoom in a little.
Okay. Do a Command plus a few times.
Yeah, that's good. That's
Better.
perfect.
Okay, perfect. Okay, so what we're looking at here, we have an Azure samples repo, and I'll drop it in the chat after this for our new triggers and bindings for AI. And if we look in, actually, I can even just show you the anatomy of this a little bit. In that repo, you're going to see a backend. The backend is where the functions live to do things like the data ingestion, upload, and prompting. And then the front end is just an HTML JavaScript app that we've deployed as a static web app. This gives us a little bit of a user experience. And it looks like a lot of the probably Microsoft samples you've seen with AI. You get your own UI for that. Let's focus on the back end. So we have a few different files, and I happen to do it in C#, but use any of the functions languages that make you happy. Let's focus on upload. So to upload and ingest the data, at first it just looks like business as usual with functions. I'm going to have an HTTP trigger where I'm going to send files and file streams as a post. And you can see we can take an array of file paths, and then we'll crack them, get the streams, and we'll actually have the file stream response. What I'm going to do here, I'm being a little bit fancy, but we have some tuples where we could deal with the uploaded response first by returning an OK result. And notice here, for those of you who are .NET programmers, we're using real ASP.NET with real iAction results, and I get like a real OK object result. So I'm excited to see that language support and stack support shining through. But also, we're going to queue up some work. In general, when you're doing a lot of data processing, I like to do it async, and I like to do it using queues and messages. So we just went the extra step, and we're going to queue this data up, and we're going to start, creating that queue of content to embed. And then you can see that once we've queued up the data, we have a service bus trigger that will receive those queued documents off. And then we're going to go create the embeddings. And this is where we're starting to see some new work. So we have this embeddings store output binding, and that basically can take a file or a pointer to a file or a URL, and it takes a few inputs like, hey, what's your vector database? I'm using Azure AI Search, and I have a named index here. And then I also choose the model. And so I'm using one of the standard embeddings models like ADA20. And one thing I'll kind of call out here is that even though we make this incredibly easy with just basically one attribute or one decorator, it is really flexible. Like, I'm able to pick the vector database. We support a few right now. We're going to keep adding more. I could also choose the model. So basically all the things that you would want to change with the SDK, you could actually do here right in the embedding. And then in just like effectively two lines of code, 1, 2, that's all we need to do to create embeddings. And so that's like kind of part 1. We're ingesting and uploading the data. And then part 2 would be asking with a prompt. And so here the user does an HTTP trigger, which will take their prompt. And you can see we're going to get the prompt right off the post request. So it just comes in here as an attribute. And again, for an ask or a prompt, I can choose the models. So I'm choosing the chat model. I'm reasserting what the embeddings model was. And that's all the information I need to basically issue a prompt and chat my own data from the vector database and return a result. In this case, I'm going to get a nice POCO object result. So hopefully that made sense. Just to kind of summarize, there's a semantic search trigger and binding, and then there's an output binding for outputs, and that will kind of create the embeddings for you. And now you've got all the building blocks you need to do a full RAG scenario. One more thing for extra credit. Let's say that your prompts contain information that your model doesn't know how to answer, what you can do is use this new assistant skills trigger right here, and you can map, hey, any new prompt I see, like in this case, if the user starts talking about creating tasks, we can say, oh, like whenever someone talks about creating a task, I want you to call this function, which actually has an object model that knows how to create a task, and let's say push it to Microsoft 365 or your favorite kind of task provider. So this is like a really cool way, if the model doesn't know how to do something, you can extend it using a function. So that's all the code. Now I'm going to switch over to um, the browser, and let's just take a peek at the demo. We don't want to look at that one. We want to look at this one. Okay, so I mentioned there's a static web app in the front, and then it's kind of a front end to the back end functions. So like we saw, there was a function for asking. This UI will help with that. And I also showed you uploading, and this part of the app will handle this. So let's go ahead and I have some private data. In this case, like let's imagine I'm Northwind and I'm in the health business. I have a bunch of documents here that describe the plans, and I can upload these as a stream. Those will all get queued up and processed. Boom, there we go. And then I can ask a question about the plan, and this is really fast. Does my plan cover eyes? Here we go. I'm getting the actual answer against my own data. And even I get a reference to the document that contained it. I can also do more, like how do I reach customer support? And answer in the style of a pirate, which is really important for your business scenarios. There we go. Perfect. So I can see all aspects of doing a search against my own data. I set the temperature such that I really don't allow a lot of hallucination, but I can still allow for style. One other thing, I did deploy this using Flex consumption. And so let me show you a little bit of the anatomy of this. Actually, let's go to the resource group. So here's the resource group. That's got to look very small. So we have here's the function. And you can see each one of those functions when deployed shows up as a named function here. So we're really using that ask function. We're working with the embed content, and we're doing the uploads. So these are literally the functions that we were calling through HTTP. And then underneath, they were queuing and embedding for us. Also, one of the really interesting parts of this is the vector database. So here we're using Azure AI Search. It used to be called Cognitive Search. And if I go into here, I can pop into indices. Here's that named index we are prompting against. And if I even search the data, I love to do this. This kind of makes it interesting. When we're uploading those documents, like we just did that, you can see that the function converted those all to vector embeddings. So here's all the vectors. And this is actually kind of what's actually used for the AI search. So it kind of shows you all the building blocks working together. And by the way, the functions, they have some controls over how chunkings and embeddings are done. So we have some good docs on that, and you can pop into the host JSON and configure those to work with different kinds of data you'll receive. And then one other thing I like to do, here's our live metrics. Like Thiago's been showing, note that we have an instance online, probably just servicing this monitoring dashboard. I really need to investigate why it's not 0, but I do think it's the inspection effect. But if we go ahead and come back to our app, and let's upload some more data. Let's do a whole bunch. We can see that Flex consumption is really going to help us burst, scale, and handle that ingestion. There we go there. Boop. And we should see, so we got a spike of requests here, and based on the surge, we popped open 6 instances just like that. And if I go back to Visual Studio, I had a gist. To remember which one of these is the Gist Explorer. Gist Pad. I love this tool. So here, what I've been playing with is I just have some environment variables for the resource group and the service, the function, and that's exactly what we're just looking at. And I set the concurrency to 5. That seemed about right. Now, of course, if I want to really go nuts, I could change the concurrency and make a CLI command. And in just a second, there we go. I can see the ARM JSON. We set per instance concurrency to 1. We'll come back here. We could go to the function. We could restart the function. It's restarted. Let's look in the JSON view. Here we go. And so the per instance concurrency is 1. So this is just kind of a live demo showing you how easy it is to fine tune this. And let's see if we can force it to do anything interesting. Let's come back here. Let's ingest a whole bunch of data again. There we go. And let's see. That is, there we go. Okay, so we're taking on more service this time. So just, it's kind of interesting to do these experiments and play with the concurrency like Thiago's been saying. Setting the concurrency lower will be more expensive. So it gives you more horsepower, but it costs you more. So actually, to get more efficient, you want to set the concurrency a little bit higher. But just for drama, I like drama, so I was setting that. All right, did I miss anything, Thiago? Is that a decent enough demo for you?
Yeah, that covered the whole end to end, and I really like the power of those OpenAI extensions where you can, through lines of code, you can create embeddings, save them to output blobs, and do a whole end to end solution like this.
Thank you.
Thanks, Paul.
Yeah, you really get all the building blocks you need. If you want to take the stage back, I'll figure out how to get back to the browser.
All right. Cool. So that was that demo, and we're pretty much at the end here. That's all we had to show you. I hope you enjoyed it. Feel free to connect with us on Twitter. I am at NZTHIAGO, and Paul is at Paul YUK. Ping us there, and we look forward to seeing what kinds of applications you build with all these new features that we've released for Flex Consumption. With that, we'll see you either in July or August, depending on how the schedule goes for the next live stream. Appreciate everybody for joining, or if you're watching the recording, thanks for watching as well. Any closing thoughts, Paul?
No, go try it. Let us know what you think. We're hanging out in the community. We want to know.
All right. Thank you.
Thanks.
See you next time.
See
Bye.
ya.